Our grade 11s, we're going to do nature of roots and graphs today. This is what I did the last day of the term, and I'm just going to quickly explain it again. So we have the equation gx is equal to x squared plus 3x minus 4. I sketch a graph. It has an x-intercept of minus 4 and 1, y-intercept of minus 4, and then my turning point is minus 3 over 2 and minus 6 and a quarter. So we are now going to discuss what happens, or what will the value of x be if gx is greater than 0. Now you have to look carefully. Gx is greater than 0. That usually refers to where y is greater than 0. So y over here, there is where y is 0, on that bit over there. So if I go and I have a look for which x value will I have a positive, and that's a positive. Greater than 0 is a positive. So remember, whenever we have a value that's greater than 0, it's a positive. Less than 0 is a negative. So in this case, it's a positive. So it's greater than 0, and it's not equal to 0 because there is no, the inequality is not, it's not included there. So do you see the difference between that one and that one? So that one is only greater than. So we are going to look for which x values makes y a positive value. So any x value, so usually what I do is I take a piece of paper, and that means it will be where y is greater than 0. So any value there, let me stick it on there for you. Any value where y is greater than will be that part that sticks out. But it will be the part there and there. And those two x values are minus 4 and 1. And I'm going to write the answers here below. So question A, number 1. It's where x is less than minus 4. Or it can also be where x is greater than 1. It's not included because my inequality has not been included over there. And now question 2, they ask me for which x values will gx be equal to 14. And now what is gx actually? Gx is actually y. So it actually means y, which is gx, is 14, is equal to x squared plus 3x minus 4. So now I'm solving for x, and that is minus 18. And I can just go and factorize that. X plus 6, x minus 3 is equal to 0. So x is equal to minus 6, or x is equal to 3. So that actually means on your graph here where there is a 3, your y value is going to be 14. And also where x is minus 6, your y value is going to be 14. Okay. Righty. Now, question 3 is maybe a question you have never done before. So it's a nice challenging one. It means where gx, which is also y, but they're talking about the y of gx, the y of the graph of gx, times x is less than or equal to 0. So less than or equal to 0 means where is it a negative? Now, do you see that these two things, gx and x, are multiplying? So think about which two things can you multiply that will give you a minus. So I can multiply a plus, and I can multiply a minus, that will give me a minus. Or I can multiply a minus and a plus, and that will give me a minus answer. So that actually means where gx, so y on the graph, y is a positive and x is a negative. So now you have to look carefully where those two graphs So where the 1 value will be a positive and the 1 will be a negative. So let me go and show you where is y a positive. Let me just make it pink. So y is a positive on my graph. There and there. Okay. Now they are asking you, okay, so we're just looking at the top part here. Positive y, negative x. Positive y, negative x. So there, I have a positive y and a negative x. You all see that. Positive y, negative x. If I multiply those two, I will get a negative answer. So I can immediately write that down. That is my question 3. So my one answer will be where x is less than minus 4. And if I look there, my inequality is also included. Now let's see if we can find another value. So if y is a negative, it's there in yellow. Y is a negative there in yellow on my graph. So it will be where, if I look at the bottom part, where y is a negative and x is a positive. Now you have to look carefully. There, I have a negative y and a negative x. So negative times a negative is a positive. That's not what I want. I want a negative. So let's have a look again. Negative, 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 negative. That's a 0. Okay? And then negative times a positive x will give me a negative answer. So up till there, where x is 1. So this whole bit here, let me color it in for you. That whole bit there, I'll get a negative answer if I multiply those two things. So that will also be where x lies between 0 and x lies between 1. And let's have a look. That's included, included, included. Now question B asks us to discuss the nature of the roots. Now what is a root? A root is also an x value, an x-intercept. So when we talk about the nature of the roots, we can either talk about a real number, an unreal number. We can talk about a rational, irrational number. We can talk about an equal root or an unequal root. So first of all, I have two x-intercepts. So my nature of my roots. So basically, what are my roots like? That's what nature of roots mean. What are my roots like? My roots are real. It's a minus 4 and a 1, so they're definitely not equal. So they are unequal. Okay? They are two distinct values that I can read off, minus 4 and 1. So they are rational values. I can express them as fractions. Okay, so those are my nature of my roots. And now, sorry, this is question C. Question C. For which values of k will the graph of gx is equal to k have one real root? So that means, so this k thing basically means it's something on my graph that will give me one real root. So if I go, I'm just quickly going to sketch it roughly for you over here. Just roughly. So there's my equation, my parabola. And let me just do that turning point. It's minus 3 over 2 and minus 6. Let's just do minus 25 over 4. Okay. So, they are asking me, gx is equal to k. So that basically means there's a line, a straight line. So k is actually a straight line. It's almost like where y is equal to this. Where y, for example, if that was a 2, is equal to 2 or something like that. But let's have a look. That means that k is a straight line. So that means if I have a straight line, do you see it intersects gx? It's two graphs that intersect each other. Now they're asking me, so this is kind of something new that I'm adding to my graph. They're asking me, where will gx is equal to k have one real root? Root is also an intercept. An intercept. So in other words, there is my line. Okay. At the moment, how many roots, how many intercepts does it have? 1. Do you see it intercepts my graph only once there at the turning point? But what happens if I move that line up? So let's say I move that line up. There. How many intercepts do I have now? I have 1, 2 intercepts. Let's try another one. I'm moving it way up over there. How many intercepts do I have? 1, 2. Okay. So that's not going to work if I move it up. I want only one real root. But what if I move this line down? So there's my line. I'm only moving the line, not the graph. So do you see this line? If I move it down, there's no intercept whatsoever. So the only value that k can only be a line that is y is equal to minus 25 over 4. Now what is in the place of y there is actually k. So that will be only where k is equal to minus 25 over 4. So whenever you get these specific questions with a k, if it's equal to k, it's actually a straight line that you can substitute or that you can draw there that will intersect your graph. It's a straight line if it's equal to. So just look for that over there. Okay.